Okay, in this video, we're going to be starting assignment 10 from my Calc CD multivariable class. It's all about line integrals, and we are just doing tons of them. This is a very long problem set. I'm going to break it up into a bunch of videos so you can jump around as you need. Let's get started. So here we have f of xy is x plus yz. So this is a scalar function, and that is a big deal because when you're doing these, you have to decide are you dealing with a scalar or a vector field, because the process is very different depending on what you're doing. In fact, it feels like two entirely different concepts. And then we're going to be along the path, which is the line segment from 0, 0, 0, the origin, to 6, 2, 2, which is a pretty straightforward thing. So first up, we want to figure out r of t, which is the path that we're following. So we're going to write this as a vector function. And I'm just going to do like where we start plus delta x times t, where we start plus delta y times t, where we start plus delta z times t, writing the equation of a line in 3 dimensions. So first it's delta x is 6, delta y is 2, and delta z is 2, so we get 6t, 2t, 2t. And then when you write a line this way, you will always be going from 0 to 1. So we have this. Okay, so that's our path. Now what we need to do is we need to calculate f of r of t. So these types of line integral problems just feel like a lot of substitution to me. And once you get the hang of it, you'll also probably feel that way. So we're going to find f of r of t, which means every x in f of x, y, z will replace with 6t, every y will replace with 2t, every z will replace with 2t. So we go back up to f of x, y, z, and we get x plus yz, so it's x plus y and z. So I'm trying to color code to help out. Here I do need to simplify this though, so I'm not going to color code anymore because I don't know how I would. All right, we also, when we're dealing with a scalar function, we have to find ds. So ds is going to be the magnitude of r prime of t and then dt. So ds, magnitude of r prime of t, dt, or the norm or the length, whatever you like to call it. All right, so that's going to be the square root of dx is, dx dt is 6, so 6 squared, plus dy dt is 2, so 2 squared, dz dt is 2, so 2 squared. And then dt, all of this is because r prime of t is 6, 2, 2, which I don't know, maybe I should have written down, but it's just linear, so it didn't seem essential at the time. But I went back and did it, so there you go. All right, we are calculating the line integral along C of f of xyz ds. So this is a scalar function. Scalar functions get ds. ds is the magnitude of r prime of t dt. These are important things that you like. Okay, so now we are going to do substitutions, right? So our t values are going to go from 0 to 1. And then it's going to be f of r of t. So that's our 6 plus 4t squared, 6t plus 4t squared, I should say. And then times ds, which is the magnitude of r prime of t dt, which we calculated to be just square root of 44. And now this is just like a Calc 1 integral. That's kind of the beauty of this. So pull out the root 44, reverse the power rule, and then you're going to plug in 1. When you plug in 0, it zeroes everything out. So we are going to end up with root 44 and then 3 plus 4/3. So, I mean, it doesn't look any better, but 13 root 44 over 3. All right, so that's if you are dealing with a scalar field. I cannot figure out, I don't know if it's showing up in the recording. I've accidentally brought my cursor over here. Okay, I think it's gone. Let's take a look at the next one. So this is a vector field. So we have the vector field y squared comma x squared. So y squared, x squared. Our curve, our path is going to be y equals 1 over x. And we are going from 1 to 2 for x. So the first thing we have to do on this one, identify it's a vector field, because for vector fields, it's an entirely different process. You're going to end up doing f of r of t dot dr, and dr is just r prime of t dt. We're going to work it out, but that's what we're going toward. First, we need r of t, right? That's basically what you always need. So I'm just going to let x equal t, which will make y equal 1 over t. And then if x is equal to t and x is between 1 and 2, t is also between 1 and 2. Always go with the easiest thing you can do. It'll make your life a lot easier. We're going to find f of r of t. So f of r of t, every x that we see becomes t, every y that we see becomes 1 over t. So this is going to be a vector field still, right? So it's going to be 1 over t squared because that's y squared, and then t squared because that's x squared. Okay, we also need to calculate dr. So dr is going to be r prime of t dt. So make sure, sometimes what I screw up on these is I will accidentally find, think that I'm finding r prime, but really what I'm finding is the derivative of f of r of t. Don't do that. Go back to r of t and find the derivative of that. So r prime of t is going to be 1 comma negative 1 over t squared, and then dt, because that's just a part of it. All right, so this actually reduces down to a dot product. So I do think that for a vector field, it's a little easier than it is for a scalar field or a scalar function. So we are going to be doing the integral along the path of f dot dr. So it's a dot product, which means we'll do the integral from t is going from 1 to 2. Sorry, I was going to say 0 to 1. 0 to 1. Oh yeah, 0 to 1. Man, for a second there I thought 0 was bigger than 1. That's problematic. All right, so we do f of r of t dot r prime of t dt. So f of r of t is 1 over t squared comma t squared dot, and then r prime of t dt is the thing that we calculated, 1 negative 1 over t squared, and then dt. So this is a dot product, so you just multiply the corresponding components and then add all the products. So we're going from 1 to 2. You get 1 over t squared, and then minus 1. And again, at the end, it just becomes a normal integral, and you just kind of do it. So think of it as t to the negative second. You'll get negative t to the negative first, or negative 1 over t, and then that. And then when we plug in, nothing zeroes out, so that's kind of unfortunate, because I do like when that happens. But if we clean this up, we ultimately get negative... How's that negative 1? Oh yeah, negative 1/2. Okay, so I'm gonna do a couple more here, and then break it into another video, I think. So maybe I'll do 2 more. So 2 more. So these kind of walked us through it. The next 2 don't. We just have to identify what's happening and go for it. All right, so we have a vector field. So that's this first step. If you can identify what you're dealing with, you know what to do. So vector field, we need f of r of t. That's going to be a vector field. And then we need r prime of t dt. And then we're going to dot product them and integrate. That's what you need to know. So f is z squared comma x comma y. R is 3 plus 5t squared, 3 minus t squared, and t goes from 0 to 2. So we don't have to find the path, we can just do it. So f of r of t, remember we got x here, y here, z here. Every x becomes 3 plus 5t squared, y becomes 3 minus t squared, and z becomes t. So we'll get t squared, we'll get 3 plus 5t squared, and we'll get 3 minus t squared. You gotta be really careful when you do that substitution. I mean, maybe that's obvious, but be really careful. Remember my caveat here when you're finding r prime of t dt, don't do it based on f of r of t, which I do a lot, which is why I'm reiterating not to do that. So we're going back up to r, and it will just be each of the derivatives. So we're going to get 10t, a negative 2t, and then a 1. And then don't forget dt. All right, so we are doing the integral along c of f dot dr. So it's a dot product. T goes from 0 to 2. That was given. It's a dot product of f of r of t dot r prime of t dt. So with this, you actually do the dot product, and we will end up with 10t cubed minus 6t minus 10t cubed, and then 3 minus t squared. Obviously, there's not a lot of like terms, but there's something, right? We can get rid of these. And then our integral becomes this. Reverse the power rule gives us this. Then we plug in 2, we plug in 0, and we clean that up. We get negative 26 over 3. So I think as I go through this, I'm going to assume for the most part that you can just do the, once we get it down to like a Calc 1 integral, and just like show the work for it. And you can always pause or rewind or slow it down or whatever you want to do. All right, let's do one more in this video. Number 5, f of xyz is x squared plus y squared plus z squared. R is cosine sine t, and then 0 to pi. First thing you want to notice, this is a scalar, right? That's telling you what to do. So for a scalar field, we find f of r of t, which is just going to be a scalar function. I guess like you're always finding f of r of t, but it's a question of what do you end up with, right? Here we'll get a scalar. We need ds, which is the magnitude of r prime of t dt, and then we just do the integral. So let's do it. We got to find f of r of t. So every x becomes cosine, y becomes sine, z becomes t. So we're going to get cosine squared plus sine squared plus t squared. Okay, and this sine squared plus cosine squared is 1, so we should really rewrite this as just 1 plus t squared. We need to calculate ds, which is the magnitude of r prime of t dt. So that's going to be the square root of the derivative of cosine is negative sine squared plus the derivative of cosine, the derivative of sine is cosine, so cosine squared, plus the derivative of t is 1, so 1 squared, or whatever. This, again, you have a sine squared plus cosine squared, so that's 1, plus the other one. This just gives us root 2t, dt, root 2 dt, not t. Okay, we are doing the integral of, over the path, f of r of t ds. Okay, so just do your substitution. So t is going to go from 0 to pi. F of r of t we found was the quantity 1 plus t squared. Make sure you use parentheses there so you correctly distribute. Ds we found was root 2 dt. And now this is just reverse the power rule, evaluate, get a really gross answer that doesn't clean up, so I'm just going to leave it like that. Okay, I'm going to stop this video here. I will be back in the next one to continue on. So I hope this was helpful, and good luck.